Let's take a look now at the derivative of an inverse function. So let f be a function whose domain is on the interval I. This is an I, kind of looks like an L or something. If f possesses an inverse, so if the inverse exists, then the following statements are going to be true. If f is continuous on its domain, then the inverse function will also be continuous on its domain. If f is increasing on its domain, so it's monotonic increasing, then f inverse is also increasing on its domain. If f is decreasing on its domain, then f inverse is also decreasing on its domain. If f is differentiable at c, so there's some value x equals c, that f is in fact differentiable, and f prime of c is non-zero, okay, so if the first derivative at c is not equal to 0, then the inverse function is also differentiable at f equals c, because f equals c, that's going to be the y that would put into the inverse function. So here's the theorem. Let f be a function that's differentiable on the interval I. So here we go. That's an I again. If x naught is a point of I at which f prime of x naught is non-zero, I'm just kind of repeating what I said up here a few moments ago, then f inverse is differentiable at y naught equals f of x naught. See, that's that y I'm talking about right here. And the derivative of this thing, f inverse prime of y naught, is going to be equal to 1 over f prime of x naught, where once again y naught equals f of x naught. Now, what may be a slightly easier way to write this piece, because that does look kind of confusing, is if I simply say I'm going to use d dx of f inverse of x equals 1 over f prime of x naught, where this x, because we write the inverse function as a function of x, where this x is actually y naught, the value of f of x naught. Now, let me whip out a quick proof for you, because the proof is pretty simple on this, and it's kind of cute. So d dx of f inverse of y naught is equal to the limit as y approaches y naught of f inverse of y minus f inverse of y naught over y minus y naught. That's just using the definition, the limit definition for a derivative. There's nothing special going on there at all. Now that's going to be equal to the limit as y goes to y naught of f inverse of y, by definition, is in fact x, minus f inverse of y naught is, by definition, x naught, divided by y is in fact simply f of x, minus y naught is going to be f of x naught. Well, that equals the limit as y goes to y naught of 1 over f of x minus f of x naught over x minus x naught. I could put parens on here so you can see that. And what that is that it's simply equal to 1 over the definition of f prime of x naught, which is exactly what we said the derivative was going to be.